Before the factory ovens ever heat up, the journey begins here in the endless golden fields. These mechanical giants are the first step in the industrial food chain. Precision blades sever millions of stalks per hour with unrelenting efficiency. Inside, violent centrifugal force separates the prize from the waste. Modern agriculture relies as much on data streams as it does on diesel. Within minutes, tons of raw wheat accumulate, ready for transport.
The transfer must happen in motion to maintain maximum efficiency.
A river of potential bread flows at hundreds of bushels per minute.
Every single kernel here is destined for the slicing line.
Coordination between the harvester and the hauler is critical. With the harvest collected, the raw material begins its long transit. Leaving the farm, the cargo enters the logistics network. Time is a factor. Freshness standards are rigorous. Before baking, the wheat must be stored and milled at massive scales. Every ounce is accounted for upon arrival. Gravity does the work, emptying the trailer in seconds. From here, the wheat is no longer a crop, but an ingredient. Stored safely, the raw wheat waits for the transport to the bakery. The raw harvest is pulverized into the fine white dust that forms the backbone of the recipe. Specialized pneumatic tankers are required to keep the ingredients food safe and dry. 30 tons of flour are loaded in less than 20 minutes. Once sealed, the cargo begins the final leg of the journey to the bakery. A synchronized fleet of ingredients converges from different corners of the country. The logistics chain operates 24/7 through all weather conditions. Destination reached, one of the largest automated bakeries in the region. This facility runs non-stop, consuming ingredients as fast as they arrive. Strict biosecurity protocols mean every delivery is logged and verified.
Clearance granted. The payload enters the production ecosystem.
These silos hold enough raw material to bake 1 million loaves a week. Precision docking is required to connect to the facility's pneumatic system.
The driver's job isn't done until the tank is empty.
Manual labor bridges the gap between the vehicle and the factory. A perfect seal is vital. A leak here would create an explosive dust cloud. High-pressure air forces the flour out of the truck and up into the silos. The transfer begins, moving tons of flour without a single human touch. Now inside the walls, the ingredients await their transformation. While ingredients arrive by the ton, the human workforce arrives by the shift. Running a bakery of this magnitude requires a small army of operators. Security is tight. Unauthorized access to the food supply is strictly prevented. Every entrant is logged, tracked, and verified before touching a single crumb. The transition from the outside world to the clean zone begins here.
Street clothes carry contaminants, so they are shed for sterile factory whites.
Hair is the most common contaminant, so total coverage is mandatory.
Even footwear is regulated to prevent outside soil from entering the production floor.
Hand washing is not a suggestion, it is a timed, monitored ritual.
Hospital-grade sanitation standards are applied to every shift. Only after the cycle completes does the system grant entry.
Rotating brushes scour the soles, while sticky mats trap the final dust particles.
The final barrier is the air shower, designed to blow away microscopic debris.
10 seconds of high-velocity air ensures the clean zone remains compromised.
We have Prince 10,200 entered. We have now entered the heart of the operation.
This cathedral of stainless steel is designed for one purpose: speed.
Operators don't bake by feel, they bake by strict numerical parameters.
The ingredients we saw arriving are about to meet in this steel vessel.
Automated valves route the specific flour blend to the correct production line. Every ounce of flour passes through a high-frequency sifter to aerate the powder. Centrifugal force pushes the flour through microscopic mesh screens. Powerful magnets act as a final firewall, catching any microscopic metal shavings. Gravity feeds the cleaned flour into a precision scale, accurate to the gram.
While flour is automated, micro-ingredients like salt often require a human touch.
Dosing screws deliver exact ratios of seasoning to the mix. Yeast is sensitive to heat, so the water must be chilled to near freezing. Temperature control is the secret to consistent fermentation.
Many industrial breads use a liquid sponge starter fermented for hours beforehand.
This living brew creates the distinct flavor and texture of the final loaf.
Chemistry is constant. The acidity must be perfect before the sponge is used. Once approved, the liquid starter is pumped forward to the mixing hall. The automated system confirms that all components are prepped and staged. The preparation is complete. Now, the transformation begins. Hydration is immediate, triggering the chemical bonds of the gluten. At first, the machine moves slowly to incorporate the raw materials without spilling. Once combined, the gears shift to high speed for the development phase. This violent energy aligns the protein molecules into elastic strands.
The computer measures the motor's resistance to know exactly when the dough is strong.
In just 12 minutes, chaos is organized into a structured, living dough.
Gravity takes over again as the batch is released.
Half a ton of dough drops into the divider hopper in a single motion. Efficiency dictates that no product is left behind between batches. The giant mass must now be broken down into individual loaf-sized portions. Volumetric pistons measure the dough by space, not weight, for high-speed output. Rough chunks are ejected rapidly, each weighing exactly the same. Any portion outside the weight tolerance is instantly rejected. Powerful pumps force the thick, sticky starter toward the main production line. The rounder stretches the outer skin, creating a smooth, tight tension. Fats and oils are measured last, ready to soften the dough. Now shaped, the dough needs a brief rest to recover from the stress. They enter the pocket proofer for a short nap, allowing the gluten to relax.
8 minutes of rest makes the difference between a tough loaf and a tender one.
Rested and relaxed, the dough is now pliable enough to be shaped. Large rollers expel the gas bubbles, creating a dense, uniform sheet. A simple drag chain catches the leading edge, beginning the rolling process. Rolling the dough creates the internal swirl structure seen in every slice. Meanwhile, the baking pans are prepped for their arrival. A precise coating of vegetable oil ensures the bread will release after baking. Cross-graining, cutting and twisting the dough creates a stronger crumb texture. Robotic timing ensures the drop is perfectly synchronized, thousands of times an hour. The scale of production is mesmerizing. A river of raw dough. For perfectly square sandwich bread, the pans must be capped with a heavy lid. They enter the matrix, a massive steam room designed for the final rise. High heat and humidity reactivate the yeast for one last explosive growth.
Operators monitor the environment closely. Too dry, and the crust will crack.
Over the next hour, the dough triples in volume, filling every corner of the mold.
It is a slow, spiraling ascent toward the heat of the ovens.
The rise is complete. The dough is now fragile and full of gas.
The pressure builds, creating the dense, square shape we recognize.
There is no turning back now. The raw dough enters the inferno.
The tunnel oven is the factory's engine, running at 400 degrees. Direct gas fire ensures an even, penetrating heat that bakes from all sides. Sensors monitor the core temperature, adjusting the burners in real time. The dough undergoes oven spring, expanding to fill the sealed pan completely. 20 minutes later, they emerge, sterile and fully baked. Magnetic conveyors strip the lids, revealing the golden crust for the first time. The result is a uniform, symmetrical loaf, identical to the thousands before it. Gentle vacuum pressure lifts the loaves without crushing the soft structure. The hot pans loop back for cleaning, while the bread begins a new path. Free from the metal, the loaves are fragile and steaming hot. A final protective mist is applied to seal the crust and extend shelf life. Computer vision analyzes the browning level of every single square inch. Anything too dark or too pale is instantly removed from the stream. To prevent condensation in the bag, the bread must now travel 2 miles to cool. This spiral tower allows thousands of loaves to air cool in a compact footprint. Steam escapes slowly, solidifying the starch structure inside the crumb. After 6 minutes of climbing, the loaves are stable and ready for slicing. Descending from the cooling tower, the bread enters the final high-speed zone. Descending from the cooling tower, the bread enters the final high-speed zone. Every single loaf is scanned again to ensure zero metallic contamination. Every single loaf is scanned again to ensure zero metallic contamination. Traffic is managed perfectly to feed the hungry slicing blades. Traffic is managed perfectly to feed the hungry slicing blades. Razor-sharp bands move at 60 miles per hour to create the perfect slice. In a fraction of a second, a single loaf becomes 22 uniform pieces.
Blades are replaced every shift to prevent crushing or tearing the soft crumb.
Rails keep the slices standing upright. A collapse here would jam the entire line. A jet of air opens the wrapper, and the loaf is shoved inside instantly. The fit is engineered to the millimeter, too loose, and it looks stale.
Rotary brushes twist the neck, preparing it for the iconic plastic clip. The color-coded clip seals the package and stamps the expiration date. Traceability is absolute. Every bag is stamped with a batch code and timestamp. Even after baking, weight is verified to ensure the customer gets full value. 60 loaves a minute merge into a colorful stream of finished product.
At the end of the automation, human hands are still the fastest way to crate.
The trays are designed to stack without crushing the soft bread inside.
Robotic stackers build perfectly aligned columns ready for transport.
The production line ends here, but the logistical challenge is just beginning. While the factory roars outside, the lab operates in clinical silence.
Dimensions must be exact to ensure the bread fits in standard toasters.
This machine mimics the human finger poke, measuring softness and elasticity. Data proves whether the crumb structure is airy enough or too dense.
Machines measure physics, but only humans can judge flavor and mouthfeel.
A rigorous score of 9 or higher
is required to release the shipment. Water activity is critical. Too much moisture encourages mold growth. Packaging integrity is tested to ensure it survives the rough truck ride. With the lab's seal of approval, the inventory is unlocked for shipping. Back on the floor, the approved product is already moving toward the exit. The digital green light triggers the physical movement of the stock. Speed is essential. Freshness is a decaying asset. While the city sleeps, the distribution fleet begins to assemble. The distribution fleet operates on a precision schedule, syncing with the ovens. The dock leveler creates a seamless bridge between the factory floor and the road. Loaders work in a Tetris-like rhythm to maximize cubic footage. 10,000 loaves are loaded into a single trailer in under 30 minutes. Once loaded, the cargo is sealed to guarantee chain of custody security.
Freshness is a race against the clock, and the driver knows the route by heart.
FIFO, first in, first out, ensures the customer always buys fresh.
While one loaf is sold, thousands more are already being mixed back at the plant. The cycle never stops. The factory is a living organism that never sleeps. From raw wheat in the field to the packaged pallet, the transformation is complete. Efficiency, chemistry, and engineering combine to feed millions daily.